Okay, hello everybody, and I'm going to introduce ourselves. Gian is our IT specialist, and myself, Gustavo, I'm the project manager of the project that we are working in with this innovation that we are going to tell to you. Maybe for the one that are not familiar with Techint, Techint is a group of company, more than 30,000 employees. Right now, we work in different countries as Techint International Company, engineering company. We have more than 20,000 employees right now and working in different countries, different projects, EPC, and different kind of contracts. Okay, what we faced. We are going to talk about what's problem we're trying to solve with this innovation, how we're dealing with our progress, and how we are working. This is a water conversion project that move water from the dissolved plants at the sea level up to the mining. That is 4,500 meter high. This is copper mining in the north of Chile. The project needs or consists in one pipeline of 44 inches plus 5 pump station of 5 pumps in this stage plus 2 the second stage, one transference station, one terminal station, and several pools for emergency. Okay, what's the problem we're dealing with? Part of the pump station are conformed by piping system that move water for different equipment and facilities. These piping systems in this project is internally coated by epoxy, liquid epoxy, to avoid the corrosion and to be able to resist 20 years of continuous operations. This piping is divided in different spools. The spool is a portion of the pipe that is limited by the flanges to be able to erect on field without the need of welding or painting or any kind of extra work. We decide to subcontract and to build the spool in a fabrication facilities in Santiago, Chile, which are far away from here. The main problem is that we need to deal with the adjustment spool. Which is an adjustment spool? Is the last spool that connect a line of already erected spool with one equipment, a pump, filter, a valve, any fixed equipment. This last spool, the green one, needs to be really precise, because you need to be sure that no liquid will occur after the direction. Then there are a traditional sequence of working and the new one that we developed. The traditional one is you pre-manufacture the adjustment spool on manufacturing, you send it to or bring it to field, and then you take the last measurement according to the actual position of the two flanges and adjust, cut, weld, test, coat, and then you put each pipe, each spool in the final position after the on-field adjustment and working. This takes several resources and time and effort in the worst place, in outfield, instead of manufacture this kind of spool on the right facility on factories. To be able to run, to be able to measure all of this pipe, we say, okay, what option we have? One is the one I already told. The second is, okay, we can erect the fixed part, the equipments that are fixed to the ground, then start erecting the rest of the spool. and let the last portion of the spool free to measure the actual measurement, the actual position of the two flanges, and measure with any kind of device, tool, instruments, then correct the shop drawing and be able to send to the factory to manufacturing in the final actual condition. This method needs a solution that we didn't have at the past. That's a tool able to measure two flanges in a real position with less than 2 millimeters of errors. Then we start to work with different ideas, option, testing, and trying to avoid to move spool from the factory to the field and then back if something goes wrong. Any small distance, a small factor will lead to big problem to the project, or we can't fit the attachment spool, or it will leak during the in-service test. Then when it's something really precise, to use any tool to use to be able to measure the two flanges with an error less than 2 millimeters. Send this measure to the shop drawing, put there, and manufacture the spool with less of this error on site. Sorry, on factories. Okay, then we start to think in different options. If something goes wrong, there will be a lot of factors in the table: cost, time, labors. The risk of having problem, this is huge. Then we need to develop something reliable, something that will really work. We have to talk and work as a team with this kind of problem. We went to the market. We work with our IT department really close, and then we got a solution. This is the one that Gian is going to tell us. Gian?
Yeah, thank you, Gustavo. Can you please give me control of the presentation? Well,
I will keep going. Sorry.
Oh, okay, it's okay. Well, what is the answer here? What is the technology that we can implement in this project to solve this kind of problem? Well, we start propose with point cloud technology because we can obtain some benefits implementing this technology in the project just to solve this particular problem. So let's start what are the benefits that we can obtain in this process. Well, with point cloud, you can obtain a better precision of your real context. You can obtain a kind of simulations and analysis. You can make a planning, project planning, or optimization of your project. You can make a control quality in your asset, and you can make a kind of reverse engineering, and then you can obtain an as-built 3D model. Those are the general benefits to implement point cloud technology in your process. But in this specific problem, we are talking about regarding to other benefits. Please, Gus, you can go to the next slide. Well, before to start with the problem that Gustavo said before, we take an advantage of the spool dimensional control process when we were in the spool prefabricated workshop, because we want to improve our internal process, and we want to make sure that the productive spool that will be sent to the project will have the correct dimension. So before to start with the adjustment spool process, we start with the dimensional control of the productive spool. So what happened here? We take all the measures of the productive spool and compare with the isometric draw, just to make sure that all the the length or the dimension of the spool are right. So Gus, please, next to the, well, let's start here with the particular solve of the problem that we are talking about. Well, this is the methodology that we defined to solve this problem. What we can do here? So we just start just to put the laser scan between the two flanges, just to take the measure of those elements, and can catch all the particular dimensions between those elements. So we only take one scan per two cases. For example, if you have two flanges, you have to only take one scan, and you actually you can only put the scan in one place for any case. So what is next? We process the information. In this case, when we process all of those information that we catch in the real environment, we start with please, Gustavo, next to the next step. When we process the information, we create a bundle with a point cloud. When we are talking about bundles, it's a kind of merge with all the points that we obtain in the place, and then we generate a LGS file. This is a specific format that we use to analyze this result after this process. So we obtain this particular file and go to the next step, that is point cloud analysis. In this case, we make a kind of simulation of those spools, the last part of the productive spool and the connection with, for example, equipment, and made a kind of simulation and project both center lines and see what is the difference between those lines. Of course, we have a lot of kind of situations, different situations. We could face off with two spools in front of each other's. We can see 90 degrees with the connection of all of the spools. So in this particular software, we use Cyclone 3DR. We made the projection of those spools and take all the measures that we need to make sure that we want to use it to fabricate our best adjustment spool with the correct dimension or with the real dimensions that we catch in the real site. And then we go to the next step is to generate a 3D result. And what happened here? We take the result, the simulation that we did in the Cyclone 3DR, and convert this projection in a 3D model. Of course, we can use a lot of kind of formats of the 3D model, but we use a particular format that can allow us to process it in our 3D design standard tools. So in this case, we obtain the 3D model, and then we go to the next step, that is generate the isometric draw version. This is a new isometric draw version that we can obtain in our 3D design software. You can use Smart 3D, CutWorks, BreezeCut, for example, but in our case, we use our standard tool in the company to import this 3D model and configure the 3D model just to obtain a as-built model. And then we generate the isometric draw with a new version, of course, making sure that it has the correct dimension that we catch in the reality. So what happened here? We submit this new version of the isometric draw. We send it to the spool prefabricated workshop just to start with a fabrication process, and then we obtain the new adjustment spool with the correct dimension that we obtain in the field. So we go to the next step, that is to deliver this adjustment spool to the project. As Gustavo told you before, it's a very large distance between the spool prefabricated workshop to the project. Is more or less 1,118 miles or 1,800 kilometers. So it's a very large way. So we delivered the adjustment spool to the project. Well, let's finish with the last step, that is the adjustment spool installation. We present the adjustment spool in the correct place that it have to be. Well, we obtain a benefits that we can get saving time and save money, because we mitigate all the risk, all the possible errors that we can obtain with a possible wrong manual taking measure in the site. So what happened here? We go to the return of investment. It's very interesting to tell you that this is a particular case, because we made the analysis. Of course, this is a conceptual analysis, just to obtain what is our benefits, what is the return of investment in our case. What are the investment that we did? In this case, we bought all the hardware investment. We spent more or less $70,000. It's the same case in the software investment. We spent almost $10,000, and we spent more or less $10,000 for training and implementation, of course, just to define the methodology, just to move forward with all the training, just to know how to use the laser scan, how to use the software, just to all the people that we that are facing with this solution have to be able to use all the hardware of the software that is necessary. So what are the savings here? The savings, just to a very specific and interesting number, we have more or less 150 adjustment spool in the entire project. So we calculate a kind of loss that we can obtain if one of those adjustment spool has a round dimensions. Well, we can take a loss of more or less $5,000. So if we are generous about all the percentage of all of those 150 adjustment spool, we can take only the half of those adjustment spool. For example, we can consider only 75 adjustment spool to give. Okay, it's possible that all of those 75 adjustment spool could be wrong with wrong dimension, and we can obtain this loss in the project. So if we have this 50% of adjustment spool with a wrong dimension, we can obtain a very big loss for $3,075 loss in the project. So if we calculate the return of investment for us in this case, we can obtain that. Please, next to the next step, we can obtain that this return of investment is about the 24% of the total in the of all of those 150 adjustment spool in the project. So it represents, of course, 18 adjustment spool to take all the investment that we spent in the first time, well, obtain the benefits that we need. It's very interesting, and it's very good to say that when we bought this laser scan to this specific problem, we can use this scan to a lot of kind of product that we could have in the company or in this particular project, because it's an active asset for us, so we can use it for any purpose that we need. So go to the next step. We can say that the summary of this purpose of this kind of solution, that we can obtain a first time adjustment spool fit up, because if we make sure that we are taking the real dimensions on the reality, we can take all the dimensions to fabricate the adjustment spool with the correct dimension that we need. So we can say that we have to implement this technology to obtain a first time fit up. Well, we save time, we save cost to the project, because if we mitigate this kind of problem in the project, we obtain some benefits about it. We reduce on-site reworks, as Gustavo told you before. We can reduce man-hour hours in the project. For example, the operators project, crane, lifting hours, the particular cost that we have to spend for the spool adjustment spool modification. So we can reduce all of those kind of reworks. And then, as I showed you before, we can obtain a fast and guarantee return of investment in this particular case. But of course, those are our numbers. It's a conceptual numbers just to see what is the return of investment in our case. Well, finally, I would like to see if you have any question about this technology, about this kind of solution. So if you have any question, please be free to ask us.
Hello guys, Alejandro here. Alejandro Aguirre, sorry for joining late. Can you hear me?
Yeah, sure. It's no problem, Ale.
Sorry, I had a problem here. Okay, I really appreciate your presentation, which was a success case for innovation in Techint. And I would like to know a little bit more about the experience you had using the scanner, how the personnel from our project, how did they receive the proposal, and if it was easy to implement on the, let's say, on the inspection side, how inspectors took the initiative and how did they, let's say, receive this proposal.
Okay, first, Alejandro, this is not easy to handle because a mistake in this process will lead a big problem for the project, time, cost, and effort and quality problems. We took baby steps during the last 90 days. I would say 6 months when we started. Then we bought the equipment. According with each baby steps, we got some confidence with the tool, and we started to get good results, and people got involved. And I think that everybody now is in the same page. This is the way it works. We are doing pretty well.
Okay. And our client, is it surprised by our proposal and this way of working?
Yeah, the client is happy with time, mainly with the time saving, more than the cost. The time saving is driving here. This is a fast track, when the mining need water as soon as possible, and this is a big asset to completion of the project on time.
And this there's a very interesting here thing, if you can share with us, is which is a recommendation if other company wanted to go this way. What would you recommend to other construction companies or inspection companies?
Okay, you need the qualified people to go to this path, but this is the future of the construction. Using different kind of devices, working on cloud, 3D measurement, 3D interaction with the real life. This is something that's starting to be the future of the construction. We need to deal with, we need to get along with, and that this is the way of working.
Yeah, I also think this is the way of work, and whenever a digital initiative comes to our, let's say, to our knowledge, we pay a lot of attention and we try to make the best of it, knowing that digitalizing is the way to go. I don't know, I don't want to take all the space, but is there any other question from the audience? I don't see any questions written there. Oh, there's a hand there. There's a hand.
I cannot see the chat, so I cannot see if you have any question.
I'm happy to see the question. I see one just came in. What method did you use to match scanned geometry of piping components to 3D design software piping class elements? Would you like me to read that again?
Yeah, could you repeat the question, please?
Of course. What method did you use to match scanned geometry of piping components to 3D design software piping class elements?
Yeah, well, in our case, we use a Smart 3D as a standard tool for all the 3D design. Of course, we have a lot of kind of situations. So first of all, we defined the center lines of all the spools and take the measure between the both flanges, you know. So we use the Cyclone 3DR to make this analysis reality. Well, we can export this analysis in a 3D model, or if we, as Gustavo told you before, this is a fast track project. So if you have a very short time to solve this kind of situation, you can make a red line, for example, directly in the isometric draw, just to improve your time. But of course, you will not have a as-built 3D model. This is just a comment about it.
Thank you, John. We have one more question here. How long would it take from the time you performed the scan to the time the new spool was delivered to your construction site?
Well, taking all the measures inside, in the field of the project, is a very quick task, because a scan could take more or less 3 minutes, 4 minutes per scan, and we only need one scan per situation, per two flange, for example. So we only need one scan per situation, or in extremely case, we can make 2 scans. So we could say that it could take us 10 minutes just to take the measure inside. But when we start with the process and analyzing process, in the Cyclone 3DR, for example, it could take, of course, more hours. It depends of the case. But in a prom, we could, in average, we could say that 2 or 3 hours per case. Of course, this is a very meticulous task. You have to take all the measure with a very specific care, because if you made a very or a little mistake in this point, you, of course, we will have a adjustment spool with a wrong dimension. So we have to invest all the necessary time to take correctly all the dimensions of the analysis that we need between the two adjustments, the two flanges. Sorry.
I understand that the second point of the question is how long it takes to get the actual pipe on site from the measurement. I can say that this project, we're far away from the factory. You can think in 4 weeks. 4 weeks between the measurement is already taken until the final spool is on site.